Okay. Let's make sure we don't, yeah? I know. Yeah. So let's make sure that we, as this is now running, let's make sure that we've covered a few things. Now, I had a quick chat with a few of you during our break, and a few people sort of said, well, can you say a little bit more about the modeling, the last bit, because that was a bit quick. And another question I had was, how do you define rural and urban, and what does this mean for the population, for the modeling? What does the clustering mean for the modeling? So what I'm thinking is, while we are now slowly getting into the practical bit, of this session, can we see, sorry, this is getting a bit tight here. So let's make sure that we've got all questions answered before we move on. Right, this is done, and I'm going to have to come back to it. So, 2 questions, something about the modeling. Can you say a little bit more about the modeling? And the other question was, what do your results on clustering mean for the health part? And go on. Right, do we have any other questions? Any other questions? All right. Don't worry too much about the details of the practical. I'll get into this in a minute. All right, we'll get into this in a minute. Right. Any other questions? So I'm going to talk a little bit before we start. I'm going to talk a little bit about clustering. A little bit about the clustering and a little bit about the multiple linear regression. Anything else? Anything else? One? Yes?
On the last histogram that you showed that was combining everything.
Yes.
I was wondering what based on rank attributes take a bigger percentage to show that maybe this will mean this household is poor. I mean, why would you take the source of water and take a bigger multiple compared to maybe the number of people in that household?
Is this one? Sorry. I don't have a page down in this. There we go. Is this the one you're referring to? All right. So this is not a histogram, by the way. It's not a histogram. This is showing us the parameters of the model and how much they contribute to the model.
How were you determining?
It's the same question. Okay. We are back. We are back. All right. Right. I haven't done this before. All right. The power comes, it goes. It's difficult. So we're going to have to work with and without power. So one question was about, very sloppily written here, was about the clustering. And, one of your colleagues wanted to know, like, okay, so what is the outcome of the clustering? How are you going to use this? Because what I had in mind was to say, okay, what is the social division? So I grouped together these data points, then I did the clustering, and I just said, give me the 3 clusters, and let me see what is happening with the 3 clusters. Again, it is not, you need to work on this, and you need to work with the data that you have. It's not a silver bullet. It's not like you're saying, okay, I'll do a clustering, divide it into 4, 5, 6 parts, and then see what is going on. But in this case, we had 3 solid clusters that corresponded to clearly very poor, very rich, and people in the middle. When we are in the middle, when we're looking at the middle class, we can see that there are more subdivisions in there. Go on. Let there be light. Or sound. No, it's all right, it's back. It is back. Okay. So we got something like this. I was interested in social division. Poor, middle class, rich. The good thing about there we go. Great. Okay? The good thing about hierarchical clustering, the way it has worked here, is that if we were to focus on this cluster, which seems to be the bigger, okay? This cluster here. See, that branch. So that is the whole right. This is the whole data set. It is broken into 2, and then this cluster is broken into further 2. If you look at this cluster, which is the bigger one, it has more strata in there, more layers. The middle class is composed of layers, still. It is composed of two large clusters. Maybe it's upper middle class and lower middle class. And then the lower middle class is further subdivided into more class. So you can see the bigger picture, which is very rich, very poor, and middle class, and then look into middle class even more and see more groupings. Remember what we said. So we can see areas of this feature space and what is exactly happening in there. The way I like to picture this sometimes is like you've got clouds, actual clouds, all right? And the clouds have little shapes. Like when you look when you look at the sky, you see shapes in the clouds. It's very similar to cloud watching. So your colleague made the best question of all, like, so what? So what? Okay, if you wanted to use, I was trying to make an observation. So I was trying to let the data speak and say, these are the social classes in Tanzania. But if you wanted to use it for an intervention, so you turn it around now and you say, well, this is the social division, what can we do? You could use the clustering to pitch the price of your intervention. That's probably, if you have worked with the economists may have seen something like this before, right? There is no point in coming back with an intervention which no one from the population can afford. So how do I fix the price? How do I say, or the other way around, when you're planning and you're saying, what is the top? How far can we push this? It's a little bit like saying, if your intervention is going to cost $20,000, 20,000 shillings, Tanzania money, which was the new thing for me again to get to grips with, 20,000 Tanzanian shillings. How many people can afford it? 50, 100, 200, 300, 400,000. As you're going up, you are going towards this side, the people who can afford it. As you're going down, you're going closer to this side. So you could say, let's look at the middle class. The middle class is the majority, let's say, and say, okay, how much is the middle class making? What is their expendable income? How can we fix the price of our product so that the market doesn't say, this is too expensive for me, I cannot afford it. All right? So this is the other, working the other way around. Not only making the observation, but then having the observation drive your decision. And I'm going to leave it there for the clustering. So let's say, observe stratification of population. And act. And now we're coming to the second most popular, maybe, question, which is, how did you get here? How did you find out these numbers? And how, why these amplitudes? Why these strengths? This is the output. This is the top of the iceberg. What has happened here is this embedded, I don't have the mouse now. That's okay.
Do you want a mouse?
No, it's okay. So this is the standard output from the tool. Remember what we said when we talked about our best line fit. In best line fit, you are dealing with two things. One input, one output. One input, one output. If X is blah, then Y is going to be blah. How do you capture this relationship? F of X is an alpha times X plus B. B is the intercept, which is where does the line meet the y-axis. Alpha is the slope. It's not the angle directly, it's related to the angle, but alpha gives you the slope. So high alpha, very steep line. Low alpha, shallow line. Negative alpha, that thing goes down. So we've got a negative relationship. In this case, we have a very large number of inputs. And because of the way numbers work, some of the fields which are you have it or you don't have it, or some of the fields which are pit latrine, field, other, 99, this, that, and the other. So for one field, instead of having a number, so instead of having, say, a quantity, I don't know, Q, which is a real number, I have a category. Can you spot what is the problem with a category? Zero corresponds to pit latrine, 1 corresponds to bush, 2 corresponds to VIP, 3 corresponds to whatever. What is the problem with categories. You can't measure increase or decrease. Are we all clear with that? Right? 1 is male, 2 is female. With numbers, if you do 2 times 1, you get a 2. Does that mean that 2 times male equals 1 female? Or you turn it around. 2 times a female equals male. It doesn't make sense. And if you leave it as a category, this thing is going to think that you've got integers there. The numbers don't know what is a toilet. The numbers don't know what is a, okay? So if you leave it as a category, if you leave it as 0, 1, 2, 3, the problem with this representation is that 0, 1, 2, 3, 4, these are numbers, and they have specific relationships between them. 4 is 2 times 2. But for us, 4 is the bush, and 2 is VIP. So it's not that 2 times VIP equals bush, right? So we have a problem, and this is why we have to turn the categories to numbers. So what do? For each one of these categories, you make this a binary decision. You have it or you don't. And you go from one field with 5 responses to 5 fields with 2 responses. This is why, you can see here, I've got a lot of things which are repeated. In reality, in the file, I don't have has thatch roof, has cement base, has earth base. No, I have only one field. What is the base? What is the floor made of? What are the walls made of? What is the roof made of? That's what I have. But to make the numbers work, I have to break it down. All right? This is why we get these strange things. Main wall material is sun-dried bricks, and then main wall material is poles and mud. This is one field in the dataset. But to feed it into the modeling, I have to turn it into a binary field. And so, where before you had one number that went from 0 to 5, you now have 4 columns. Is 0, is 1, is 2, is 3. So if it is 2, you get 0, 0, 1, 0. If it's 1, you get 0, 1, 0, 0, and so on. Then it can work in the way that it works with the maths. So then it's a bit like saying, this thing either contributes or not. So it's either 1 or 0. By the way, you could choose it to be whatever, but you have to be consistent. It could be 100 or 0, but it should be 100 or 0 for everyone. All right? Otherwise, we get distortions. So what we are doing, once we have converted our categorical fields back to the binary fields in the way I described, then we feed everything into an ordinary least squares. And what we say is, I want you to find the best line that goes through all of these attributes and predicts the wealth index score. It is exactly the same thing as when you do best line fit. So you can, best line fit, you have one input, one output. In our case, we have 25 inputs, one output. 25 inputs, which are the attributes. What is your wall type? What is your... 27. In fact, 27 before you break them down in this way. after you have done this, you get like, I don't know, 50, 70, something like this. But essentially what you do is, and now it doesn't look like a line anymore. All right? Okay, so how does it look like? It looks like a plane. So 2 dimensions, sorry, 1 dimension is a point. In 1 dimension, I can only go left or right on this line. 1 dimension. And this is why this input in this line results in output in this line. If you know where you are here, you know where you are there. 2 dimensions is a plane. 3 dimensions is a plane. Sorry. 1 dimension is a point. 2 dimensions, it becomes a line. 3 dimensions, it becomes a plane. Can you imagine how does that look like? Remember our example. This wall is the number of people living in a household. This wall is distance from the market, and that direction is distance from the health center. So a plane would look a bit like this. Disaster. So you put that's when I poke the eye out. So you put a plane in here. What does this tell you? It tells you that if you track any one of the points on this plane, it corresponds to a y right there. So 2 dimensions here, 1 input, 1 output. In this example, 3 inputs, 1 output. And this plane can have whatever orientation in space, okay? Who determines the orientation? The values, the data points, okay? So it might be a plane which is like that. It might be a plane which is like this. It might be a plane that fits like that. It might be a plane that fits like this. But all along, what I'm doing is I am taking all the points that conform to this surface and put them on a, so create a model that all of the points that correspond to this surface give me an output. It is exactly the same thing as best line fit, but in a different space. Okay? So multiple. The output from that is what we see there. Remember what I did with this. You orient it in space. Who is telling you the orientation? The coefficients. The coefficients determine the orientation. And the coefficients tell you how strongly each one of these predicts your output, which is the wealth score. Remember what we said here. F of x is alpha times x plus b. B is the intercept. We still have an intercept up there. And then has electricity, has that much contribution, where it says coef. Has radio, has that much contribution. Has television, has that much contribution. In addition, you get the standard error, the t value, the test for significance, and confidence intervals. From this column onwards, are we clear what this means? No. Are we all clear with the t-test and p-values and all of these things? Yes, maybe yes. All right. From this column onwards, the data that we see there tells us how significant is that coefficient. How reliable? Should I say, yes, this is something that, so yes, has electricity is contributing very much into my model. And it is based in a very simple way. But as you can see from almost there, so let's say has radio is this value. We are looking for values which are less than 0.005. Some of them are above in this case. So what I did in the beginning was to feed all 27 coefficients. It came back with some characterizations, and then I took out the non-significant ones, ran it again, and that's what we see here. Okay? Zoom this one. I'll try.
So the negative coefficients are the ones that point to the left, and the positive coefficients are the ones
Yes.
that point to the right.
And then, so this is how this diagram was created. Positive coefficients, negative coefficients. And the wealth index goes positive and negative. At the end of the day, all right, let's now turn it on its head. We found our coefficients. What does that mean? It means that I have recovered my A and B. That's what you do when you do a best line fit. You recover your A and B. But in our case, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 23 maybe, 20, something like that. A's and B's, coefficients. How do I work the other way around? I go to a place and I look at the houses and I start ticking boxes. Okay? You start ticking boxes. Is the residence rural? Yes, tick that box. Is the water source protected? Is the water source a protected public well? Yes. Bang. Is the water source river dam? Yes. Bang. To work out the wealth index, you do the weighted sum of the observations. Is the residence rural? Yes. This amount times 1 plus this times that plus this times that plus and so on plus the intercept, you get the wealth index score. All right? So this is how I can work backwards. Now I have the model. And this model is summarizing all of our observations. So now we can use it the other way around. Now we can use it for prediction. Knowing the model, I can go to an area, tick boxes, and have a calculator come back and give me the wealth index. So when the door opened where we are living up in Arusha, I think it is still Arusha where we are. I'm not very familiar with the area yet. We walked into a house which is bricks, cement, septic tank, water piped into the house and everything. So I could tell that the owners were more on the upper class, all right? Which is different than when you walk into an average house in the UK, when you walk into an average house in Greece, when you walk into an average house in Italy, and so on. So this is the profile of Tanzania. If you did the same thing for, say, Greece, so these would change. If you did the same thing for Spain or whatever, Ireland, US, these things would change. But at the end of the day, this little, trick gives you a model by which you can predict the wealth index. it's a fancy best line fit. Right, we now come to the most challenging part. Okay? Yes, sorry.
Let's assume we have two parameters, A and B,
Yeah,
as opposed to the 27.
yeah,
To get a negative coefficient and a positive coefficient in
Yes.
the graph, I would say a point that is positioned at the top there could be classified as positive coefficient, and the one that is below can be classified as a negative coefficient. Can I say that?
Which one is the negative in this case?
Let's say negative A.
Negative A.
Yeah.
A is the slope.
Oh, okay.
This is positive slope, because as this is going up, this is going up as well. If this was going up, but this was going down, the line would look like that.
Yeah.
This is when you have a negative. If it was 0, it would be flat, which means that it doesn't matter what happens in your input, the output is dead, it doesn't vary.
Okay, from this diagram,
Yeah.
so we could say that that is actually a linear least-square regression. Is this a linear least-square regression?
OLS, yes.
This is linear.
Yeah. Yeah, yeah.
So we could do for higher order polynomials.
You could extend it. Yeah. Well, and then you get into other things like why third order or fourth order or fifth order, which model is best, what criteria you're going to use, and so on. That was another thing. Someone again asked me, so what? Why did you do this? From my point of view, I was trying to understand what's happening in Tanzania, what's happening from the data before I see, without having direct experience. But this is like a set of most common tools. Someone comes to your desk and they land you a file and they expect results from you. Before you start or bring in all these big guns, non-linear models and neural networks and the big tanks are coming in and parallel computing and big data and all that. Fine, but I need to understand what is in there first. And yeah.
Did you try to check for violations of OLS, like multicollinearity?
Yes. Yes. This is why I said that. So the model has come back and says the smallest eigenvalue is that which indicates that there is strong multicollinearity problems. To make it more specific, so what? So what if you have multicollinearity? Okay, remember what we said, some of the fields vary together, right? So I don't know if it's this field that contributes to the model or this field that contributes to the model. It is a little bit like saying, I have lots of these cases. Or maybe no, we have to go to a third dimension to really see the multicollinearity there. But when you have conditions like these, this will manifest itself when you have fields that co-vary. This will manifest itself in the eigenvalue of the system that the computer is trying to solve. The computer is trying to solve a system of linear equations, right? That's how you get all these coefficients. That's how you know how to position this plane. And the computer looks at the matrix and it says, well, if the matrix eigenvalue is so low, it is very possible that a lot of the points in here are codependent. Exactly. That's how you understand you're in a problem area. But after this comes the difficult part, okay? So now we have an idea. Now we know. 9 o'clock in the morning, we had no idea what we were dealing with. now we know a little bit more. Now we can start bringing in the heavier stuff. So, you know, you do this, you have a first report, you approach your I don't know, line manager, boss, whatever, and you're saying, this is what is happening. The next step is, I don't know, neural networks, whatever. But 3 very simple tools by which you can understand what's happening. Sorry, there was another question? Yeah? Yeah?
Okay, mine is about looking at the spatial dimension of the analysis. Because until you have
Yes.
an understanding of where each class of citizens found, it becomes difficult for it to start applying your...
If you don't mind, I'll answer this a bit later on. What was the other question?
I've done some resistance.
Yeah.
And I was using the decision tree.
Okay.
It has a tool for finding future importance.
All right.
So, would you eliminate some of the features there?
I did. So these are the eliminated ones. When you will get the code, the lines of where I started from are commented. So I started with these lines and I write down, this is what I did in the beginning, then I eliminated some coefficients, this is the model that you see on the web page.
So these are the final ones.
Yes, this is the final, but still we have some which are not significant in this case. We still have some of the, so that wouldn't be the full model. You can still pick out coefficients from this one. Right? Was there another question? Okay, let's get back to the spatial modeling. So what was exactly the question? That you have something like this, but you now want to take the spatial dimension into consideration. Right. Okay, so this is a bit trickier. All right? This is a bit trickier. So, spatial modeling. What is space? Because at the end of the day, everything that we do breaks down to numbers. The mathematics don't know what is a blood pressure. Mathematics just see a number going up and down. 2 numbers, systolic and diastolic. Even more, if you ask a doctor about blood pressure, they give you 25,000 different answers. It's incredible. You know? Anyway, so how do we quantify space? Well, you can say I've got a longitude and a latitude. And these are 2 numbers. And I can take into, because they are real numbers, I can just put them into my model. And then the model might come back and tell you there is a negative or a positive relationship with latitude. So if you are closer to the equator, your conditions are these. If you are far away from the equator, your conditions are these. Is that clear? Okay? But there is another way to take into account location, space. Remember what we did before. Do I remember what we did before? So you take your area, and instead of having latitudes and longitudes, you can create a new, let's call it covariate, where you now map distance to how far away you are from a specific point. So you could then map, create a new number, a new covariate, which is distance from the city center, for example. In fact, this was one of the things that came up in the modeling, but it was not significant. So I got a -16 with distance to the water source. What does that mean? -16 coefficient on distance from water source. it was insignificant. But if you didn't know about the p-value, I'm just saying I got a minus 16 coefficient on distance from the water source. The attribute distance from water source contributes 16 negative points to the wealth index. Or the further away you live from the water source, the poorer you are. But that's only a 16, a minus 16. This one is plus 30,000. Minus 16 is nothing, right? If you answer yes or no on this question, you have accounted for so much of your total variation. So this minus 16 was like nothing. It's the difference between 23.25 and 23.2572. All right? So this is how you would take into account the space, the spatial. You can either take it literally, so latitude, longitude, or you can create zones. It's a little bit like with age groups. Have you worked with age groups?
Yes.
Right? Instead of taking an age as it is, 23, 24, 32, 36, you bin it into age bands from 0 to 18. Or income levels. Yeah.
Let me
Yeah.
clarify a little bit.
Okay.
First one I really meant was the former spatial aspect.
Yeah.
It's the location. So for example, if it was about you want to help a community,
Yes.
let's say water sources, but you need to know which communities are the most needy, so that you know where they're located, and then you can be able to extend your service there. So if this data was, say, georeferenced, then I want to also look at how I can analyze this spatial, so that you can be able to.
In a way, it depends on what you're working with. This is not a very helpful answer. I realize that. But in here, there was no latitude, longitude. But there is the area. Dodoma, Arusha, Zanzibar. What else am I forgetting? What was it? Dar es Salaam, yes. 8, isn't it? 8 regions. Isn't there 8 regions in Tanzania? Or 5? So you would be able to tell down to the region level. It's a little bit like, oh, and there is also the height of the dwelling, the height of the household. Where was it? How high up in the mountain the dwelling was. So from the point of view of this data set, you're down to the geographical region. Okay, so let me turn this around. Let me ask you guys, depending on what we said here, how would you take into account the region that someone stays in? And so on.
I think you have to classify them in categories of city status or level or whatever you can put it.
We have the city already.
Or region.
So your colleague here says, why don't you classify the cities by, what was it? By?
I don't know how I can call them. Like into urban, rural, semi-rural, something like that.
I think your interest was on the actual area, geography, right? So what you're looking to get out of it is where can I target my intervention, right? So the classification on urban or rural is a secondary importance. We already have these. We already have the categories. So remember what we did before. The computer doesn't know what is a Dodoma, not what is a Dodoma. What is Dodoma or Arusha or all the rest? So that response would be a 0, that response would be a 1, that response would be a 2. Turn them into binary. Is location Dodoma? Is location Dar es Salaam? Is location Arusha? And so on. Put it in the same method, and it will come back with whether or not, so water utilization being more needed in one of these areas. But that's very coarse, because Arusha, I think if you look at it on the map, is a huge area, isn't it? It's a very big geographical region. So I think that's the level you can play with. How much time do we have left? An hour. All right, if it's an hour. Okay, let's try to make some of these things a bit more concrete, okay? And to do this, we gotta go hands-on. And that's where we're gonna have a problem now. Because some of you have Python installed on your computers, right? Some of you accessed the Python notebooks yesterday over the network. I think the easiest thing to do is to find out who has Python on their computers and try to share. If we get into something like groups of maybe 3, if we are about 60 in here, it will be about 20 groups. Do we have 20?
You can see how many people have
Yeah.
Python, right?
So how many people have Python installed on your computer and working? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we're probably there. So if you can group together with someone who doesn't have Python on their computer, and what we can do, no, I don't have it here. I will pass around a USB stick